Yeah. So good morning everyone. Myself Rohit Gandhi and I'm going to explain you about vertical axis wind turbines and the applications of vertical axis wind turbines in urban areas. So first let us understand what is vertical axis wind turbine. A vertical axis wind turbine is a type of wind turbine where the main rotor shaft is vertically aligned. This is different from the traditional turbines that that you people may have been seen, where the blades spin like a giant fan on the tall towers. In vertical axis wind turbine, the blades rotate around the vertical axis, almost like a spinning cruiser or a merry-go-round type of design. Because of this design, the turbines can capture wind from any direction. This is especially more important in cities where winds does not flow at a steady and single direction. Instead, it gets deflected from tall towers, rooftops, narrow streets, creating turbulences. So what's vertical axis wind turbines are designed to handle this kind of complex multi-directional wind flows that makes them more efficient for turbulences and city-like areas. Yeah, so let us now understand how vertical axis wind turbines work. The working principle of vertical axis wind turbines is fairly simple. As the wind blows, it pushes against the blades. Depending on the design of the blades, the turbines either work on drag force, which means the wind directly pushes the blades, or on the lift force, which is similar to how aeroplane wings generate lift. When the blades move, they turn the central shaft. This central shaft is connected to a generator placed at the base of the turbine. The generator then converts the rotational energy into electricity. The big advantage here is that unlike horizontal turbines, the generation of watt doesn't need to be placed on the generator of watt doesn't need to be placed on the top of the tower, making maintenance easier and safer. So let us understand the three types of vertical axis wind turbines and then I will tell you the applications of them. So first one is the 7S turbine. This is a simple design. It looks like an half cylinder or like an halves of an barren cut vertically and placed back to back. It works on drag force where the wind simply pushes the blades. They are very good at starting on their own, even at low wind speeds. They are not very efficient, but they are more durable and greater for small scale applications like pumping water or powering street lights. The next one is Darius turbines. There are more advanced designs shaped like an egg eater or curved blades forming a loop. It works on a lift force, so it can be more efficient than 7 years turbines. The drawback is that they usually need an external motor or a push to start because they don't have self starting capabilities. Uh, they are often used in large installations where efficiency matters. The third one is helical turbine. This is actually a variation of Darius design where the blade are twisted into an helical shape like an spiral staircase. The advantages of this twist is that it produces smoother rotations and reduces vibrations. Helical turbines are quieter, more stable, and increasingly popular in urban areas. Yeah, so let us understand the differences between vertical axis wind turbines and horizontal axis wind turbines. Vertical axis wind turbines compared to horizontal axis wind turbines are omnidirectional and do not need to face the wind directly to rotate and generate electricity. However, horizontal axis wind turbines are generally large in design and are specifically built for open areas and offshore wind farms, whereas WATs are compact and can be installed on rooftops and urban landscapes. In terms of efficiency, HOTS are higher, produces a range of percentage between 35 to 50%, whereas vertical axis wind turbines usually produce a range of current from 20 to 40%. But when it comes to noise, safety, efficiency of maintenance, vertical axis wind turbines have a cleaner advantage, making them more practical for cities. So let us understand the advantages of vertical axis wind turbines in urban environments. In cities, the advantages of vertical axis wind turbines becomes very important. First thing, the cities have higher turbulences, wind patterns due to skyscrapers, crowded buildings. So vertical axis wind turbines can handle these turbulences better than horizontal or any other energy generation source except the solar ones. The second is noise is a bigger issue in urban areas and cities. So watts are more quieter compared to other energy generation resources. And the third is the space is limited in cities. So compact rooftop friendly vertical axis wind turbines are ideal for such kind of situations. And the next one is vertical axis wind turbines can be integrated into building designs combined with solar panels for hybrid renewable energy systems or energy generation resources. And finally, vertical axis wind turbines contributed to centralized power generators or such kind of systems. Power generators or such kind of systems can help reduce reliance on large centralized power plants and improve energy resilience in smart cities. Yeah, so let us understand some kind of urban applications of vertical axis wind turbines. The first thing is rooftop turbines for homes, apartments, and office buildings. Built-in integration integrated turbines mounted on facades, balconies, sides of skyscrapers to generate electricity for that particular buildings. Then street light systems, we can install vertical axis wind turbines at a small scale to light the LEDs of the street lights. The next one is electrical vehicle charging stations in smart cities where turbines provide clean energy resources for EV vehicles. The next is public infrastructure such as powering bus stops, traffic signals, and network towers. And the next system can be an hybrid system where solar panels along with the vertical axis wind turbines can be used to generate electricity on both the times, the day and as well as the night. And we can also use it for emergency power supplies where we can use vertical axis wind turbines to generate electricity and store it in our systems so as an backup to give electricity in critical services or critical service areas like hospitals, communication systems, and so on. So let us understand some of the advancements of vertical axis wind turbine technology in this current years. The first thing is helical blade designs are made more efficient to reduce vibrations and improve efficiency. Hybrid turbines combined basically a combination of 7S and Darius rotors for both self-starting and higher efficiency are made. Then bladeless vertical axis wind turbines are also created, which reduces the noise and mechanical stress. Smart turbines with integration of IoT, allowing real-time monitoring and integration into smart grids. The next is energy storing integration, where vertical axis wind turbines are directly connected to batteries for home and office use. Yeah, so by this, I can conclude my presentation and I can say that vertical axis wind turbines offer an promising renewable energy solutions for cities. While they may not match the efficiency of large horizontal turbines in open spaces, their advantages are that they are compact, omnidirectional, quiet performance, and ease of integration into urban infrastructure, making them an ideal technology for smart and sustainable cities of the future. So, by this, I conclude my presentation. Thank you.